What is good, 7th graders? We're on our first practice link for SP34, and it says during a statistics lesson, students were told to measure the amount of sugar in 6 sugar packets. Martin and his lab partner measured masses of 2,44344 grams. What is the mode of the masses? Remember, mode is the one that appears the most often. There's more 4s than any other number, so our mode would be 4. What is the median? Okay, remember we have to put those in numerical order. So the ones come first, 3, 4, 9. And then we find the middle, cross them off as we go. 3 is in the middle, so our median is 3. What is the range? So we do the biggest number minus the smallest. 8 is the biggest, 0 is the smallest, so our range is 8. All right, what is the mean? We add all those together and then divide how many there are. So 4 plus 6 is 10, plus 8 is 18, plus 7 is 25, plus 0 is still 25, divided by 5 is 5, so our mean is 5. Okay, a cable company analyst paid attention to how many new customers it had each day. What is the mode? Which number appears most often? We have 2 5s, but we have 3 10s, so our mode would be 10. That appears most often. The week of his birthday, Harry paid attention to how many pieces of mail he received each day. What is the median? What is the middle? So we have 5 the first day, we have 8, we have 2 or 3 actually, we have 5, and we have 10. Okay, the middle, then we have to put those in numerical order, so 3, 5, 5, 8, and 10. Start crossing them off till we get the middle. The middle is 5, so our median would be 5. Okay, what is the range? Our smallest is 0, our biggest is 6. 6 minus 0 is 6, so our range would be 6. All right, Ernesto has the following data. We have 19, 20, 15, J, and 20. If the range is 5, which number could be J? All right, so they're telling us the biggest minus the smallest is 5. What does J need to be then? So here the biggest is 20. The smallest is 15. That gives us a range of 5. So that means that it could not be 9, because if it was 9, then we would do 20 minus 9, the biggest minus the smallest, which would give us a range of 11. So that would change the range, so it can't be 9. If it was 19, the biggest would still be 20, the smallest would still be 15. You'd still have a range of 5. So it has to be 19. Good. If the mode is 4, which number could be B? Now remember, mode is the one that appears the most often. So far, there's only 1 4. There's only one of each number. So for 4 to be the mode, we need another 4. So B has to be 4. If we chose 14, then the mode would be 14. But it can't be 14. And if the median is 6, which number could J be? Remember, that's a middle. We have to put them in numerical order first. So we have 1, 3, 6, 8. The middle is going to be 6. That means this 6 has to be the middle. So if J was 3, that would make 3 the middle. So it can't be 3. It's got to be 9. So that 6 is in the middle for the median. Good. If the mean is 12, what number could H be? Okay, remember we're adding them all together, dividing by how many there are, and getting 12. So 11 plus 16 plus 8 plus something divided by 4 is going to be 12, the mean, the average. So if we add these two together, 11 and 16 is 27, plus 8 is 35. So 35 plus something divided by 4 is going to be 12. While 35 plus 5 is 40. 40 divided by 4 is 10. So it must not be 5. 35 plus 13 is 48. 48 divided by 4 is 12. So H has to be 13 to get a mean of 12. Okay, how would the mode change if the number 31 were added to the set? Okay, how would the mode change if the number 31 were added to the set? If 31 were added to the set, 17 still appears the most, so there wouldn't be any change in the mode. It'd still be 17. How would the mean change if 77 replaced the number 37? Okay, so we're taking a smaller number 37, replacing it with a bigger number 77. So would the average or the mean go up, down, or not change? Well, it would go up, because if you're adding a bigger number to it, that's going to pull up the average. Okay, how would the range change if 79 replaced 84? 84 is the bigger number, the biggest number. So if we replace that with 79, which is smaller, it's going to change our range. It's going to bring our range down because 79 is smaller than 84. So it would decrease our range. How would the median change if the number 56 replaced 61? Okay, remember median is the middle. First we have to put them in numerical order. So we have 15, and then we have 3 26s. 26, 26, 26. Then we have 38, 61, 67, and 71. Okay, so if we find the middle, it's going to be between 26 and 38. If we replace 61 with 56, our median is still going to be between 26 and 38, so there would be no change. Okay, for these problems we have to look at the data points and then determine which of these things are true. Okay, so it says the Baltimore Ravens won the American Football Championship in 2013. In the same season, the Kansas City Chiefs had a record of 2 wins and 14 losses. The dot plot below shows the 40-yard dash time in seconds of the defensive backs on each team's roster. Defensive backs mainly defend against passes, and the 40-yard dash is the main measure of speed used in American football. Which pieces of information can be gathered from these dot plots? Remember that the lower 40-yard dash times are faster. So a lower time is a faster run. Okay? So the defensive backs on the Chiefs are faster on average. So we look at the Chiefs. They have higher points, higher dots. The Ravens have more spread out and some lower ones. So remember, lower times are faster. So I would say the Chiefs have a higher average because they have more dots to the right. They have higher dots. So that's not true. Chiefs are not faster on average. The speed of the defensive backs on the Chiefs varied noticeably more than the speed of the defensive backs on the Ravens. Okay, I also don't agree with that. The Ravens have a bigger range, so their points are varying more. The Chiefs have a smaller range, so their points are varying less. So that's not true either. So I would say it's none of the above. Okay, here. The times in the semifinals, which is green, were faster on average than the times in the finals, which is in blue. So the green has more dots closer together and higher. The final round has more spread out, greater range, and if you find the average, it would be a little bit lower than the average of the semifinals. So I would say the finals have a faster average, the semifinals have a slower average. So the times in the semifinals were not faster than the finals, which makes sense if you think about it too. You'd think the finals times would be faster than the semifinals. The times in the finals vary noticeably less than the times in the semifinals. No, I think it's the exact opposite. The times in the finals vary more because it has a bigger range than the times in the semifinals. So none of those again, I'd say none of the above. Okay, here's our information here. We have DX Comics, how much they spend on or make on movies. Marvel Comics, how much they make on movies. So the first one says, movies based on Marvel heroes bring in more money on average. So if I look at Marvel, they have amounts kind of spread out. There's more obviously around the 1 to 200 million. But they have some higher ones as well. So these are going to bring up their average a little bit more to around like 300 million. DX, however, more of theirs are low, so their average is going to be closer to 1 to 200 million. So, do Marvel heroes bring in more money on average? I would say yes. All Marvel movies bring in more money than all DX movies. Well, if that were true, then all the green would have to be above all the blue. But that's not true. All the green is not higher than all the blue, so we can't say that's true. Some bring in more money, but not all. The amount earned by DX movies varies much more than the amount earned by Marvel movies. So DX varies much more than Marvel. No, I'd say Marvel varies much more than DX. DX is more altogether down here on the bottom. Marvel is more spread out. So I wouldn't say that one either, so I would just say the first one. Okay, the times in the Olympic finals, which is blue, were faster on average than the top 8 U.S. qualifying times. So remember, lower numbers is faster average. So most of the blue dots are to the left, a faster time. The green dots are more to the right, a slower time. So I'd say that's true. All of the times in the Olympic final were faster than all of the top 8 U.S. qualifying times. Okay, if that were true, all the blue would have to be below the green. But there's one green dot here below these blue dots, so that one's not true. Some of them are faster, most of them are faster, but not all of them are faster. The Olympic final times vary noticeably more than the times of the top 8 U.S. qualifiers. So I would say that is true because the finals has a greater range than the qualifying, so it varies more than the qualifying.